This is algebra 2 a trig. This is 3b.3. Simplify complex fractions. So a complex fraction is a fraction that contains a fraction in its numerator or the denominator. And we're actually going to have numerators and denominators with fractions. So fractions inside of fractions, those are called complex fractions. Your textbook shows different methods for working with these complex fractions. So there is more than one way to do this. I kind of like method 1 because it keeps practicing all the methods that we've done in the past. That's a good thing. But we're going to mainly focus on method 2. So I'm not going to go through 2 different methods. I'm just going to show you one to help speed things along for everybody. We're going to find an LCD, the least common denominator of every denominator we're looking at. We're going to multiply the numerator and denominator of the big fraction by that least common denominator. We're going to distribute the LCD to each of the terms. And then we'll be able to eliminate and have our final answer. So let's take a look at our first one. What would we call the LCD? What is our least common denominator going to be? What would we need to make all these denominators become for them all to be the same? They all have to have x, and they all have to have x plus 4. Now, where some people get confused, they think that x and x plus 4 are the same x. Those are different x's. Okay, this is a binomial, this is a monomial, so they both have to be x, x plus 4. That's what we need to do. So the method 1 way would be to add these 2 fractions together and then multiply by the reciprocal to work with the fractions. That's working on adding fractions, and that's working on dividing fractions. That's a very good skill to do. But there's a shortcut called method 2 that we're working on. We're going to multiply the top fraction by the LCD, this bottom fraction by the LCD, to every fraction. So we have a fraction on top we're going to multiply it by, and we have 2 different fractions on bottom. So I would suggest to write it on both sides. That's kind of the same thing as distributing it in. So let's just look at this top fraction and our LCD. Can anything reduce? By multiplying this in here, does anything cross out? X plus 4 crosses off. And what would we have left? We would just have 5x. Wow, that made life really easy. The denominators are gone of the numerator. Now we're going to come down here. What would reduce? X plus 4 would reduce. And what would we have left? X times 1, which is 1x, otherwise known as x. What's going to happen here? The x's cross off. What are we going to have left? 2 times this, so that is 2x plus 8. Is there any simplifying we can do to this? There we go. We're done. So that works out pretty well. You got to identify what the LCD is. You've got to multiply it to all the individual little fractions. And it's kind of magic work. and it makes each of those fractions eliminate the denominator. It's very convenient. So what do we suspect this LCD is going to be? X plus 4, x minus 4. This has an x minus 4 also, so that's okay. What's this going to be when we factor it? So this is x plus 4, x minus 4. So this has one of each. So don't they all have to have one of each? You agree with that? Yeah. So the LCD is going to be x plus 4, x minus 4. This is where you've got to put your attention in. You're either just writing it down and going, yay, it's x plus 4, x minus 4. Do you know why it's x plus 4, x minus 4? So while you're sitting in here now, taking the notes, you need to spend a moment. Do I get it? Could I have come up with that on my own? So we're going to multiply every fraction by our LCD. X minus 4, x plus 4 to this top right fraction. X minus 4, x plus 4 to this top left fraction. X minus 4, x plus 4 to the bottom right, and x minus 4, x plus 4 to the bottom left. Now we're just going to work with this portion. What's going to cross out? The x minus 4 is going to cross out. And what are we going to have left? 3 times x plus 4. So if you want to take your time and it just helps you with organization, you can write it like that. Or you can distribute it right in. Minus, what's going to happen here? They both are going to cross off with that beast, right? So you're only left with the 6. That was handy. Okay, what's going to happen down here? The x plus 4's cross off, and I'm left with my 3, x minus 4. I can distribute that and call it 3x minus 12 right now if I want, or I can just take my time. This says plus. My x minus 4 is cross off, and I'm left with 1 times x plus 4. So by distributing in, I get 3x plus 12 minus 6, 3x minus 12, and x plus 4. This is where some of you, if you're ready to do it all in one step, you would write it as 3x plus 12 minus 6. Distribute it when you write it, and you can skip this step in the middle if you think you're ready to do that. So your like terms, 3x plus 6, 4x minus 8. Oh, yikes. I see something in there. Anyone else see something?
You can.
What can I reduce? I was about to say this is our answer. Oh, my bad. Nope. I was thinking a 2 came out of all these. A 2 comes out of 8, a 2 comes out of 4, a 2 comes out of 6, but a 2 doesn't come out of 3. It has to go into everything. So now, that's the best. That's it. That's our answer. That can't be simplified at all. We just had a conversation about this could be factored using 3x plus 2 and 4x minus 2. I'm okay with this because nothing reduces from it. And our denominator is only factoring out a GCF. But that's good. So we flip the page. Okay, here's a crazy story problem. A college student drives home for the weekend. The distance between her home and her dorm is D miles. Her average speed coming home is R1, and her average speed going back to school is R2. So her average driving trip is given by this complex fraction. We're doing the distance twice, there and back, and we have two different rates. It may not be as busy when you go back on Sunday afternoon, but it may be very busy when you come home on Friday afternoon. So that's why you could have two different rates. So we're just going to simplify this complex fraction. So what is my LCD going to be? This denominator is a 1, if you want to think about it like that. This denominator is R1, this denominator is R2. So for them all to be the same, they'd all have to be R1 times R2. So I'm going to multiply this guy by R1, R2, this one by R1, R2, R1, R2. Just like before. Nothing reduces here, and it becomes 2D R1, R2. Sounds like a Star Wars figure. This one, the R1s cross off, and we get D R2. And here the R2s cross off, and we get D R1. Do you see anything here? Notice we do not have a binomial on top. This would be called a monomial. It's only multiplication all the way through. So things can be reduced. Here we have a D in both of them. R1 times R2. You can put parentheses. You don't have to put parentheses, whichever you want. But here I can pull my D out, and I'm left with R2 plus R1. So my D's can cross out. So I've got 2 R1, R2. And on the bottom, if I rearrange it just for fun, I have R1 plus R2. That's the best we could do. So what do 10, 5, 2, and 4 all go into? They all go into 20. It's good to know your multiples. So I'm going to multiply everything by 20. So you might consider this one a little simpler. So let's start in the upper left. So how many times does 10 go into 20? So I'm going to cross out the 20 and the 10 and make a 2. Turn the 20 into a 2. So that's going to become 2x for the top left side. The 5 goes into the 20 4 times. So now that's going to be minus 4x. That's kind of weird. All right. Here on the bottom left, 2 goes into 20 10 times. So I have 10x. And 4 goes into 20 5 times. So I have minus 15. So it looks like I have negative 2x and 10x minus 15. Now, here, what's going to happen here? What does a negative exponent mean? That means that that value is going to go into its own denominator. So what is my LCD going to be?
K. Will it be just K, or will it be K, like K squared?
It's got to be K squared. Right? Because K squared and K squared match, so we're happy with that. K can become K squared just by multiplying by K. And this is 1, so you multiply by K squared. That would be like a method 1, and we actually do that math to every little fraction, and then we add or subtract, and then we multiply by reciprocals. This is method 2. So we're going to take our K2, or K squared is a better term, and multiply it to every term. Nothing to reduce here. So we get 4K squared. K squareds come apart, and we get a minus 1. Oh, how does that make you feel? Do you know what this is? 4K squared minus 1? That's a difference of 2 squares. We might be able to work with that next. Then this one of the K's are going to cross off, so I have 2K, and I have minus 1. So like we mentioned, this is the difference of 2 squares. This can be factored apart. Into 2K minus 1, 2K plus 1. When you multiply the 2 K's, you get 4K squared. When you do the outer and the inner, you get 0. And 1 and 1 makes 1. We have 2K minus 1 on bottom. So our final answer is just 2K plus 1. That's pretty crazy. Then our last equation down here. There we go. That was a quickie.